You know, you hear a lot of talk nowadays about countries developing their own climate action plans in order to fight against climate change. In a lot of these action plans, you hear about things like carbon emissions, carbon taxes. Now, in order to understand what these action plans are talking about, in order to be informed citizens, we need to have a better understanding of what all these carbon-related issues are. So in this video, we'll be looking at the carbon cycle, and we'll also be looking at what are carbon sinks and what do they have to do with our environment. Now, carbon turns out is a kind of nutrient that flows around in our ecosystem. So we'll also look generally at how nutrients flow inside an ecosystem. So how do nutrients flow in an ecosystem? Remember earlier, we asked the question of how energy flows in an ecosystem. And we saw that the flow of energy in an ecosystem is non-cyclic, right? It enters the ecosystem as light energy from the sun, and it leaves the ecosystem as heat. So it cannot be recycled. Is it the same for nutrients? Now the answer is nope. You see, unlike energy, nutrients are continually recycled in an ecosystem. Of course, there's a condition: the ecosystem must be balanced, meaning that the various processes in the ecosystem must be in place. And we'll take a look at some of those processes in just a while. So if those are in place, then the flow of nutrients would be cyclic. And the cyclic flow of nutrients involves various processes. And these processes involve both the abiotic and biotic environment. For instance, for the abiotic environment, it would involve the atmosphere. And for the biotic environment, it would involve your organisms, your plants, and your animals. Now, nutrient cycles are actually something that you have encountered before. Back in primary school, you probably learned about the water cycle. That's an example of a nutrient cycle, because water is a nutrient. So water cycles around due to various processes. You've also heard of the carbon cycle, where carbon cycles around. And there's also this thing called the nitrogen cycle, where nitrogen also gets recycled within an ecosystem. Now, for the rest of this video, we'll be taking a closer look at the carbon cycle. So what is it? Well, as the name suggests, the carbon cycle describes the many processes which help to move carbon around in an ecosystem. So one of the main places that you find carbon in an ecosystem is in the form of carbon dioxide in the atmosphere. And the carbon cycle describes how carbon is removed from and released into the atmosphere. So there are processes that take carbon out from the atmosphere, and there are processes that return carbon to the atmosphere. Hence, if these processes are in balance, then the concentration of carbon dioxide in the atmosphere will stay relatively constant. And this is particularly important because plants, right, need a source of carbon dioxide in the atmosphere to carry out photosynthesis. Alright, so what are the processes in the carbon cycle? Well, before we go there, let's ask ourselves where we can find carbon in an ecosystem. Well, of course, we can find carbon in the atmosphere as carbon dioxide. And we can also find carbon in plants and animals. And that's because living organisms are made up of many carbon-containing compounds, like carbohydrates, proteins, and fats. These are all carbon-containing compounds which make up plants and animals. And then when they die, they become dead organic materials, and you'll find carbon there. And some of these will then become fossil fuels over time, and so you'll also find carbon in the form of fossil fuels. So with that, let's take a look at the processes which make up the carbon cycle. Okay, so our first important process in the carbon cycle is photosynthesis. Now, during photosynthesis, plants will remove carbon dioxide from the atmosphere, and you'll use that carbon dioxide to make or synthesize carbohydrates, mainly glucose, and those carbohydrates can then be converted into other carbon-containing compounds like proteins and fats. So carbon from the atmosphere is converted into carbon-containing compounds in plants. Next, the carbon-containing compounds in plants can be transferred to animals or consumers through feeding. Right, so consumers obtain those carbon compounds by feeding on produces. Alright, and the next process would be death, egestion, and excretion. So let's focus on death first. Due to death, the carbon compounds in plants and animals become trapped in the dead bodies of the organisms. So it just remain there in the ground, locked in. And over time, some of them are even converted to fossil fuels through the process of fossilization. Now let's look at some of the processes that release carbon back into the atmosphere. So the main one would be respiration, which takes place in both plants and animals. Now in respiration, glucose is combined with oxygen to produce carbon dioxide and water. So during respiration, carbon dioxide is released back into the atmosphere. Now another process that releases carbon dioxide back into the atmosphere is decomposition. So remember that dead organic material? Well, it is broken down by decomposers through decomposition, which is a type of respiration, and so carbon dioxide is released back into the atmosphere. So the carbon that is locked or trapped in this dead organic material can be released back through decomposition. And finally, the carbon which is trapped or stored in fossil fuels can be released back into the atmosphere through the process of combustion. Right, so combustion, the burning of fossil fuels, releases carbon dioxide back into the atmosphere as well. Okay, so as a summary, I would like you to pause the video and to recap and think about which are the processes that remove carbon dioxide from the atmosphere and which are those that release carbon dioxide back into the atmosphere. So pause and start again once you've thought about it. Okay, so firstly, the process which removes carbon dioxide from the atmosphere mainly will be photosynthesis, right? That absorbs carbon dioxide from the atmosphere. But in an indirect way, we could also say that feeding and fossilization and death kind of prevent the carbon dioxide from going back to the atmosphere. So in a sense, it removes carbon dioxide from the atmosphere, but not directly. And the processes which release carbon dioxide back into the atmosphere, right, will be your respiration, combustion, and decomposition, which all produce carbon dioxide. So remember my point earlier, that if these processes are balanced, right, if those that remove carbon dioxide are balanced with those that release carbon dioxide, then the concentration of carbon dioxide in the atmosphere would be relatively constant in a balanced ecosystem. So why is the carbon cycle important? Why do we need a relatively constant concentration of carbon dioxide in the atmosphere? And firstly, we need to ensure that producers have a continuous supply of carbon dioxide to carry out photosynthesis. Why? Because without photosynthesis, energy will not be able to enter the ecosystem. And without photosynthesis, energy cannot flow through the ecosystem. Right? So actually we need a constant supply of carbon dioxide in the atmosphere so that plants can carry out photosynthesis, energy can enter the ecosystem, and then energy can be passed on from producers to primary consumers to secondary consumers through feeding in the form of those carbon-containing compounds. Alright, so we're done with the carbon cycle, and at this point, I want you to take a look at these two pictures. One is an ocean, and the other one is a forest. So what do you think they have in common? Well, the answer is they are both carbon sinks. No, not the sort of sink that you see in your toilet. But I guess in the same way that water flows down a sink, so a carbon sink is an area which absorbs more carbon dioxide than it releases. So it's kind of like a net absorber of carbon dioxide. So here's a definition of the carbon sink, which we all need to remember together. So what is a carbon sink? Well, a carbon sink is basically an area, like the ocean or the forest, that is able to store carbon compounds for an indefinite period of time. And it's able to do that because it stores or it absorbs more carbon than it releases. So take for example the ocean. Now we know that the ocean absorbs carbon dioxide from the atmosphere, right? And the ocean also releases carbon dioxide into the atmosphere. However, the ocean is able to absorb more carbon than it releases. And so it becomes like a store of carbon, right? Because carbon is absorbed from the atmosphere, more of it is absorbed than is released, so some carbon is stored inside the ocean. So the ocean becomes a carbon sink, which is important. Without carbon sinks, our atmosphere would have too much carbon dioxide, right? Because there's nothing that's absorbing that carbon dioxide and storing it away. So in the same way, forests are carbon sinks because they absorb more carbon dioxide than they release. And so they store carbon compounds. Okay, so let's talk about our oceans. They are actually our largest carbon sink because they cover, a great majority of Earth's surface area. And oceans remove carbon dioxide from the atmosphere in two main ways. Right? Firstly, carbon dioxide is able to dissolve into the ocean. So the fact that it dissolves inside becomes stored in the ocean. And secondly, photosynthetic producers will absorb carbon dioxide through the process of photosynthesis. Now, how about forests? Forests mainly absorb carbon dioxide through photosynthesis because they have lots and lots of plants. And also, when the trees die, the carbon remains stored in the form of dead organic material, like dead trees, or even fossil fuels. So you can see again, carbon gets stored up in the forest, right? It's not released back into the atmosphere because it's stored in the form of dead trees or fossil fuels. Now, carbon sinks like forests and oceans are increasingly important, especially because we humans are producing more and more carbon dioxide. So there's this term called a carbon footprint, and carbon footprint basically means the amount of carbon dioxide that is produced as a result of some activity. So in the same way that, you step somewhere and you leave a footprint, a carbon footprint is kind of like the footprint that is left behind as a result of human activity. So, all our human activities combined produce a certain amount of carbon dioxide, and that is our total carbon footprint. And our carbon footprint has been increasing, and that is a problem for the Earth because carbon dioxide, as we know, is a greenhouse gas. It helps to trap heat within the Earth's atmosphere. And that's fine, that's important. It's good. We need a natural greenhouse effect. We need to trap some heat in our atmosphere, otherwise our Earth will be too cold. However, due to our production of carbon dioxide, which is excessive, we now have this enhanced greenhouse effect, which is leading to a rise in our Earth's temperature, or global warming. So the question is, how then can we reduce carbon dioxide concentration in our atmosphere so that we can prevent further global warming? Well, firstly, we should work on reducing our carbon footprint, changing our human activities, adjusting them so that we don't produce so much carbon dioxide. Right? And you can do this through laws or agreements between countries. Countries can agree to limit their carbon dioxide emissions. Previously, there was a Kyoto Protocol in 1997, and recently there was a Paris Agreement as well. Countries can also implement what is called a carbon tax. So you impose more taxes on industries that produce more carbon. And so we can reduce our carbon footprint. But the other way is that we can actually help to preserve and enhance our carbon sinks. If we preserve and enhance our oceans and our forests, well then these carbon sinks can help us remove carbon dioxide from the atmosphere. So one way of doing that is reforestation, grow more trees. More trees equals to more removal of carbon dioxide from the atmosphere. We can reduce deforestation, cut down less trees. And there's this interesting method as well, which is adding iron compounds to oceans. And apparently this helps to stimulate the growth of those photosynthetic phytoplankton so that they can absorb more carbon from the atmosphere. But I'm sure that adding iron compounds probably results in some risk as well. Right, so we've reached the end of our video, and I hope that you've gained an appreciation of the importance of our carbon cycle and why we should reduce our carbon footprint and why we should preserve our carbon sinks. And all of us need to take action together so that we can help our Earth and conserve our Earth as it is for our next generation to enjoy as well. So I'll see you back in class.